Hi everyone, welcome back to College Algebra. Before I start, I want to talk about something. So as you know that as a human species, we've been evolving over the past 2,000 years. Since the day we developed and we proved the Pythagorean theorem, until 1990, we successfully also been be able to prove the last Fermat theorem, which have never been able to be proved for almost 400 years. So we as humans been developed, we become smarter and smarter each day. Okay, the same as universe. The universe get expanding each day. It become bigger and bigger. Since the first day, since the first moment after the Big Bang, okay, our universe is getting bigger and bigger over the time, okay, and it expanding to there's no boundary in our universe. Okay? According to the theories called the expansion theory of universe. Our universe is not just expanding, but it is expanding following a certain pattern. It expanding that its expansion is modeled by a very special curve. It's called exponential curve. Okay, whose function we call it exponential function. Today I want to talk to you about exponential function. Okay, so let's get started. Exponential function. Okay. What is exponential function? Let's talk about its definition first. Definition. Exponential function is a function. It's a basic function. Okay. It's one of the most important function in college algebra level, and it has a form fx equal to a b to the x. The a value here, we call the initial value. The a value is initial value. The reason we call it initial value because if we replace x with 0, so we have to b to the 0. So b to the 0 is 1, so your output is become a only. That's why we call a is initial value. Okay? And the b we call that exponential factor. B is exponential factor. Okay. The exponential factor here, it could be called exponential growth or exponential decay. Depends on what the b value is. If the b value is greater than 1, b's value is greater than 1, we call that exponential growth. Okay. And the curve that represents exponential curve, that represent exponential growth is something look like this. Okay. So you see that over here we have horizontal asymptote because the curve has never crossed the x-axis, and you see that when you go from left to right, the function is increasing. Okay. However, if b between 0 and 1, we call exponential decay. Okay, and the exponential decays whose graph is that look like this. So if you see that if you go from left to right, our function is kind of decaying. Okay, it's decreasing. Okay, let's get back to the theory expansion of our universe, because our universe is getting bigger and bigger each day. It's expanding. Okay, there's no boundary, there's no limit. Okay, so the function, the curve that represents that expansion will something look like this. Does something look like this? Of course, right? It's not quite like this, because our universe starts from the Big Bang, so it starts from zero. So we don't have this part right here. However, it's still considered as exponential growth, exponential function. Okay, so our expansion of our universe can be modeled by this curve, kind of like this. I would say 100% like this, but it's like 95% that look like this. Okay. So I can give you the example of exponential function. I can have something like this: f of x equal to a3 to the x. Okay. So the b value here, our b value here is positive. So this function is exponential growth. Exponential growth. Okay, function. Our initial value is 2. Okay. Of course, we can also talk about the domain and range. So if it's exponential growth, then you see the domain is also from negative infinity to positive infinity, because it's keep going up, right? And this is keep going to the left side. Okay. Our range is from 0 to infinity, because it doesn't have the lower part. So it starts from 0 to infinity, but it not include the 0. Okay, so I can include the domain and range here. So domain will be negative infinity to positive infinity, and the range is from 0 to positive infinity. The same thing for exponential decay. So the function I give here as an example is a typical example of exponential growth. Okay, now I can have something like this: f of x equal to e to the x. E is very special number, called the E number. So you can get the E from your calculator, right over here. So E is about, if you type E in, it's about 2.7. So your E number is 2.718. Okay, it's an irrational number. So over here, our initial value is 1. I didn't write it. Our base, our exponential factor is E. And over here is the exponential growth also, because your E is 2.7, is greater than 1. Okay. So I give you two typical examples of exponential function. After we understand exponential function already, how we write exponential function, how we construct exponential function algebraically, given some information, given 2 points, the coordinate of 2 points. Example 2. Okay. I want to write exponential function. Right? Exponential function. Okay. That goes through. Okay. That goes through 2 points. The first point is -1, 8. I call it point 8, negative 1 and 8. In the second point, I call it point B, is 1 and 2. Okay. Solution. Remember when you learn linear function, and when you learn linear function, there a question asks you to write linear function like a linear equation. And there are two methods to write linear equation. Is you use slope-intercept form or you use a point-slope form. Okay. Sometimes you can use standard form too. So kind of the same thing over here. I would say the same because not in terms of the way I say the same over here. I mean that the step is the same. Of course, exponential function, it doesn't have the slope, of course, right? But the step, the strategy is the same. And in order to write a function, you have to write out, the first step you have to write out is this general form. So in this case, you have to write out f of x equal to ab to the x. Then you find a value, you find a b value. As like you find a value and b value, you plug into this formula and you successfully get the exponential function. The same thing as you write linear equation, you need to get the slope, you need to get the b value. As long as you get those two, you plug it back in and you get the function. So we're going to use the information they give us to get a and b. So they say that it goes to negative 1, 8, so I can plug them in, right? So 8 here, a, b to the negative 1. Same thing, I use point B, I plug it in, 2, a, b to the 1, right? Okay. So I have a and b. The first equation, the second equation, I also have an a and b. So we're going to use substitution method. We already learned when you solve system of linear equation. Remember, there's substitution method, elimination method. But in this case, we cannot use elimination method, so we can use substitution method. Okay, that's one of the way. There's another way. You can do it like this. You can set the ratio between the left-hand side of the first equation and the right-hand side of the first equation over the left-hand side and the right-hand side of the second equation. So from here I can get 8 over 2, I set the ratio, equal to ab to the negative 1 over ab to the 1. Then I cancel a value because our goal is to get a and b, right? Okay. So a divided by 2 is 4 equal to equal to what? B to the negative 1 over b. You remember the formula when you learn when you simplify exponential expression. So you subtract same base, you subtract the exponent. So negative 1 minus 1, so b to negative 2. Okay, negative 1 minus 1, negative 2. So from here, I can change it, b 4 equal to 1 over b squared, because you have negative exponent. You can change to positive exponent by flip it up, flip it over. We already learned this in intermediate algebra. Then you can cross multiply, so you have 4b squared equal 1, and you can get b squared equal to 1 over 4. Okay, and you can get b equal to 1 over 2. Okay, we don't want to get negative because originally b cannot be negative. Okay, it's b greater than 1 or between 0 and 1. It's all positive, so we don't have b negative. So over here b is 1/2. 1/2 is between 0 and 1, so you see that this is an exponential decay. Okay, it's not exponential growth. So after you get B, you can find. Okay. You can find A value. So I plug them in. So I have 2 equal to A, B, I plug into the second one. So B half. So I got A equal 4. Okay. And I got A and I got B. I have my final exponential function. F of x equal to 4. B is 1 over 2. X. Okay. So again, in order to write any function, okay, you need to find some variable. For exponential function, you need to find A and B value. In order to find for a linear function, you need to find the slope and the B value, which is the y-intercept. Okay. So in kind of you see that I say it kind of the same. We use the same strategy as we already learned for a linear function, linear equation. Okay. And other than modeling the expansion of the universe, exponential function can be used to model with a fixed exponential rate. Okay, they have a lot of they use exponential function in many real-world applications. Especially they use that in the bank. If you guys major in finance, okay, you also use a lot of exponential function. So on the second part of this video, I want to talk about application of exponential function. Okay. I think all of you guys are working, right? Everybody have a job here. Maybe you have a part-time job or full-time job, and you guys have a certain amount of money in the bank, right? And you want to deposit your money into the bank, and you try to pick the bank who give you the best interest. So for the second part of the application, I want to talk about how we're gonna use exponential function to understand how the banks is working. Okay, how they make money. How you can earn money by put your money into your savings account or your money market account. Okay. All right. So exponential function can be used to model something. It's called simple interest rate. Okay. It can be also used to model another fixed rate. It's called, I don't say it's fixed rate. It can be used to model, how I'm gonna say that. Let me see. First of all, I say the simple interest, right? It can be used to model a continuous compound interest also, or it can be also used to model let me see, a continuous compound interest and the compound interest over a certain period. Okay, so we're gonna go through each of them, and we will compare the difference between among those applications. Okay, so first of all, I want to talk about a simple interest. Okay. What is simple interest? For example, like this, you have you make $200, okay, and from work, right? And you put $200. Oh, let's make it $100. You make $100 from work, and you make a deposit. You deposit that $100 to your bank, okay? And the bank say that each year it give you 1%, okay? Okay, and it's fixed, okay? And so after the first year, 1% of 100, it gives you $1. So after the first year, you make 101, okay? So this is a different right. This is important right here. So the second year, you also earn money from the bank, okay? But it's not just $2, but it's only $1 also, because they say that they give you only 1%, okay? Okay, they just give you 1, and it's based on the principal, the original amount you put it in, you make deposit, okay? So on the second year, you have only $102, okay? The second $1 you earn from the bank is based on the original principal, the original amount of money you put into the bank. That's why we call it simple interest, okay? That's different from the compound interest. Okay, for the compound interest, that's what we're gonna we're gonna talk about that after simple interest. The compound interest, okay, is the interest, is the money you receive from the bank based on the original amount and the interest you make after the first year. Okay. So for the simple interest. This is the interest, okay? Okay, this is a method of calculate interest, calculating interest, where interest on interest is not applied. Okay, it means that on the first year you make $1 because out of 1% interest, but the second year is also $1. It's not the second year is not. The money you make is not based on 101, but it's still based on $100. Okay, the original amount, okay, you put into the bank. Okay, that's why we call it simple interest. I can give you the example. Oh, before I give you the example, I need to give you the formula first. I'm sorry. So the formula to calculate the simple interest is A equal to P, okay, plus, okay, P naught R times T, okay. Okay, P naught is the initial amount you put it in, okay. So this can be written as P naught 1 plus RT. Okay. So the part over here, the term P naught times RT here, we call that amount. Is amount of interest. Okay. So I want you to memorize that formula. Alright. Let me see, I can give you the example. Let me see, we have the example here, not? see. Example. Let's see, they have the example, simple interest. They should have it somewhere, so guys, try to find it. Let's see. I already wrote it down here, but I leave it somewhere. I couldn't find it anymore. Simple interest. Let me see. Okay. 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 If $5,000, okay, is invested, okay, at 4% simple interest, okay, for 18 months, okay, for 18 months, okay, find amount of simple interest earned, simple interest earned, okay, part B. So find the total amount of money after 18 months. Okay, solution. Okay, so how are we going to do this problem? Of course, you see that when you read the question, you know right away this is simple interest. Okay, and because it's a simple interest, you have to use this formula over here. So on the first part, they asked you to find the amount of simple interest. So this the amount of simple interest right here. P naught RT. P naught is the initial amount, this amount of money you put into the bank to invest. Okay, T is the time, R is the rate. So T over here must be in years. Okay, it must be in years. R is the rate, percent, okay, and P naught is initial, the principal. Okay, principal. Alright. So we have the initial amount is $5,000. Here you want to invest $5,000 in the bank, right? The interest right here, so R right here. That's 18 months. It's in years, but we need to change it to this is in months, so we have to change it in years. So 18 months is 1.5 years. So we can do the amount of simple interest. Okay, we call it I equal to P naught RT. Okay, the amount of simple interest we call I. Okay, and we plug in P naught is $5,000. Phi R is 4%, so which is 0.04, right? And T is 1.5 years because 18 months we converted to years is 1.5, and we calculate them out. It just gives you $300. Okay, what does it mean? It means that after 18 months, you earn $300 extra from $5,000. Okay, then the total amount of money you have after 18 months will be A equal to $5,000. Okay, plus, right, plus 300. Then you have totally is $5,300. Okay, and you're done. So that is one of the application for exponential function. Using exponential function, it's a simple interest. We can use simple interest to model a compound. We can use exponential function, to model something called compound interest, and we will see the difference between simple interest and compound interest. Okay. Second part, compound interest. So for the compound interest, this is kind of investment where the interest on the interest is applied. Okay, interest on interest is applied. I already give you the example before, and I said if I put $100 in the bank, right, the first year you make $100.01, but the second year you will not make one more extra dollar, but you making more than one extra dollar, because the amount of money is not based on $100 anymore. The amount of money is based on $100.01. Okay, that's why that's the difference between compound interest and the simple interest. And the formula we use for compound interest will be A equal to P, okay, 1 plus R, same thing, N over NT. T is same thing. T represent years. Okay, R represent the ratio, the interest, a percent, and N represent the number of compounding. What it means over here is that you can compound annually, you can compound weekly, okay, you can compound daily, okay. So the amount of money you earn will be different, depends on how you compound it. Okay, you can also compound annually, monthly, weekly, and daily. Okay. So for the compound interest, I don't think any bank in America use compound interest. Most of the banks use simple interest because so that you can make less money from them. This is the bank, they greedy, so they don't want you to make money from them. They never give you compound interest. Maybe they apply the compound interest when you put your money into your money market. Maybe, I'm not sure. I'm not really. I don't really know much about the money market, but I know that when you put money into a money market account, you make more money than the saving account. Okay, so maybe they use compound interest over there, and of course the N, they're not compounding daily. I think they're compounding even for money market, and they use compound interest. I think they compound it annually. Okay, it's not daily. Okay, if it compound daily, then of course you make more money. Okay. So if you compound annually, your N equal 1 for compound annually. Okay. N equals 7 if you compound weekly. Yes. Okay. N equal 365 if you compound daily. Okay. And N equal to 12 if you compound monthly. And N equal 4 if you compound quarterly. I don't know any account that compound quarterly, let alone daily. Okay, so I think most of the account, even this money market account, they compound annually. So they, you make a little bit more money than simple interest, but you don't make a lot of money. Yeah. Okay. And later on, when we're talking about when n equal to infinity, we mean you keep compounding. We call it continuous compounding. That is the best case. No banks in the world, or no financial company in the world that give you that you can invest money using continuous compound interest. Okay, when n is infinity. Okay, we're gonna talk about that on the third part of application. Okay, let me give you the example of this compound interest. Okay. Of course, I'm going to give you an example where we have the case when n is, I think, I'll just do one case when n is monthly. So when n is equal to 12, but you do the same for any other things, okay? Okay. Example. Suppose that $5,000, again $5,000, is invested and pay 6% per year, and pay 6.5% per year. Okay. When compounding, okay, quarterly. Let's do quarterly. Okay. All right. The question is, determine the total amount of money after 10 years. Determine amount of money after 10 years. Okay, after 10 years. Solution. Very easy. You know right away this is compound interest and it's compound quarterly, and of course you have to use this formula. It's not simple interest, so you don't use this formula. So you just plug it into the equation. A equal to your P naught is 5,000. Okay. 1 plus R is 6.5, so we 0.065 over. And quarterly, so n equal 4. Okay. N equal 4. T is 10 years, so 10. Okay. So you put it into calculator, and you got your answer easily. So your answer should be 9,527. Okay, you can put it into your calculator. I'm not doing that. $0.79. So you see that at the beginning you have $5,000. After 10 years, you have $500 more. It's not really good, right? I don't think it's good. After 10 years, you have only $500 extra. It's not really the best one, right? All right. Okay. So I mentioned that there's the best compounding. It's called continuous compound. Okay. Continuous compound is when you have n equal to infinity. Okay. And when we have n equal to infinity, I'm sure that the amount of money after you put your $5,000 in the bank will be more than 10 years compound quarterly. Okay. And I can prove that by using the information here, but I will apply the formula when we have a continuous compound interest. Okay, so on the third part, this is continuous compound interest. Okay, and formula for continuous compound is A equal to, which is when n equal to infinity. Okay. When n equal to infinity, that formula can be converted into A equal to P, not E to the RT. E number is the number I already showed you in the calculator. Okay, so I'm going to use the information here so that we can easily to compare the amount of money after 10 years, so you see which one is better. Okay, of course the continuous compound interest would be better, but how much better? Let's see. P naught is $5,000. E R is 0.065 time T is 10. Okay, let's see. Put into a calculator. Let's see what we have. Okay, so I have $5,000, right? Time, right? E, put E number, raise it. Okay, 0.065. Okay, time 10, which is give you 9,577. Okay, 9,577.7. So you see that it's a little bit better. It's just a little bit better. It's 577, it's 527, so about $50 more. It's not a lot though. I mean, to us it's not a lot, but remember, this is the bank. So they try to get your money. Okay, so to them, $1 is a lot. Okay, so let alone let alone $50 over here. Okay, so you see that's a big difference. You know, the compound quarterly is not as good as continuous compound interest. But the thing that you never have continuous compound interest. You never have compound quarterly, let alone continuous compound interest. You know, I remember I switched all the amount of money I had in the bank from saving account to a money market account, and after 1 year, it won't change much. You know, you don't believe me, you go ahead and talk to the agent in the bank, and you want to switch it. You say that you want to switch it to the money market, and you will still won't change. But a little bit, maybe $10 more, but maybe like $5 more. Not a lot after first year. Okay, so it will make a big difference. That's why there's a lot of things. You can invest a lot of ways you can invest your money, but there's more risk. Okay, you can play stock. Okay, if you know how to play stock, you can make money out of that. You can invest your money and use play in insurance, whole life insurance maybe, but that is very long term investment. Sometimes it's like for the rest of your life. Sometimes it's 30 years, 60 years. So that's just very long term. I talked to my cousin. He's a very good investor, and he said that he wants to do investment for a short period of time, and he said that the only way to do investment for a short period of time is you have to play stock. So the more risk you have, the more money you can get. Yeah, but I mean more risk. I mean, you might lose money too. Okay, especially at this moment, right? A lot of people losing money because the virus, because of the economy, right? You know, the virus affect everything, right? Including economic also. So a lot of people lose money too. So there's some risk. There are risks you have to take, okay, to make money. You don't want to take risks? There you go. You can put money into your saving account. That's it. And each year you make $1. But anyway. So I mean, I will explain more when you go to pre-calculus, but this kind of overview, I think it's gonna help you somewhere somehow when you do business. Yeah, so I don't think this is very it's so hard because all you have to do is first of all you have to memorize the formula. Then you have to read your question carefully, because when you read question carefully, you see right away what kind of investment they're talking about. You can see you can tell right away they want you to use the continuous compound, or regular compounding interest, or the simple interest compounding. Okay. Alright, so in the next video I will be talking about another concept in exponential area topic. We will be learning how to solve exponential equation. But before learning that, I want you to spend a little bit of time reviewing all the exponential formula we are learning intermediate algebra, all the all the method that is used to simplify exponential expression. That is very helpful if you memorize that formula. Otherwise, it's very helpful for you to solve exponential equation. Okay, I think that's all for today. If you guys have any question, put your question on discussion board. Again, so far I have not seen any question on discussion board. It's kind of strange to me. You guys have to watch video, okay? Even though I know the test we take home, the final we take home, just think about it. You know, you don't learn to pass this course. You learn for yourself. You learn for your career, for your future. Okay? Then I'll see you next time. Alright? Goodbye.